Good evening, ladies and gentlemen. Welcome to the November edition of the APAC AI user group, running out of Brisbane and a couple of other places, namely Sydney and Wellington. I hope everyone's doing well on this fine Thursday, and everybody's looking forward to Christmas coming up. So our group is predominantly run from Brisbane. And our intention for setting up this group was to actually introduce everybody to the field of AI. So any beginners or any intermediates that want to learn, please feel free to connect with us, and we'll take you through them to this field. If you want to reach out to us, as you can see on screen, you can reach out to us on using LinkedIn. We've got a LinkedIn group. We are active on Meetup, and if you want to submit a session, please do so by going to that GitHub link. Raise it as an issue. Alternatively, if you want to hear about a topic, raise it there as well. We'll do our level best to actually get that done for you as well. And also our Twitter handle is available. Okay. So what I'll do before we get started, quickly, a couple of quick housekeeping things. I've got a couple of my co-presenters on the stream today. One of them is Surmi, who I will introduce you to shortly. She'll be going through some news. Then we'll get our presenter, Michael, to go through the session, and then we'll handle Q&A. Q&A, please feel free to put them into chat, and we'll ask the presenter as we go along. And a big shout out to JK, who's doing Q&A for us this evening. Okay. And with that, what I'll do is I'll introduce Surmi. Surmi is an MVP in the AI field with Microsoft. She'll go through some interesting news that have come through in the field of artificial intelligence. Surmi, it's all yours.
Thanks, Sarad. Hi, everybody. Thanks for joining us tonight for another session of our meetup and user groups. As Sarah mentioned, I'll be sharing a few news that I found interesting in the past month or so. The very first one that I want to talk about is Neon. I'm not sure if you guys have heard about it. Samsung has introduced its artificial human bot. They're not going to call it chatbot because they're keen to say this is not just an assistant. It's more of a conversational partner that they are introducing to the market. So this has been introduced at CES last year, and it has showcased in various scenarios where Neon can help. It is actually called Neon. So it's a humanized version of AI bot, which is in a human form as well. So they are claiming that it can be used in different sectors like finance, healthcare, retail, and TV sectors. What it uses Samsung Core R3, which is based on reality, real-time, and responsive, and it uses also Spectra technology as well. So they are using the human-based algorithm or human-like algorithm to give the more humanized interaction to the customer or experience to the customers. One of the examples that they mentioned it can be used is, for example, it can be used as a backup news anchor for the late night news that they can use. So it's actually not to replace our job. It's actually as an assistant that can be used. And it doesn't work like current chatbots or available assistant that we have, for example, Alexa or other home assistant that we have, which is like a chatbot and like search within the Google and gives us an answer. It's more of a humanized version of the interaction that we'll receive. There are a few videos that I found interesting regarding to that one. I'm going to play one of the videos that it kind of introduced what it is and what technology it uses behind the scene. And there's another video that I'm going to share the link later in the chat that you guys can have a look, which is kind of contradictive opinion around the Neon and how it can be helpful or not. I believe there is a lot coming to this one because this is, I guess, the next generation that is going to happen within our AI world. And it's going to be interesting to follow up that one as well. Let me play that video for you, and then we can talk after. I hope you guys can hear that sound as well. No, just one.
Neon's artificial human avatars were the viral. bit of CES before the show had
One thing that they are trying to use is they actually partner up with one of the South Korean financial institute to use Neon as their customer personnel teller and financial advisor. So it's going to be interesting to see what feedback we receive from that experience or that pilot that they started using. So I'll share, if I find more details around it later, I'll share that in our next news section that we're going to have. The next news that I'm going to share with you is...
It had everything the internet...
It's we talked about before our session, we were talking about where AI can go next, and this news can be interesting as well. Google has announced a new AI architecture, which is they're going to call it AI Pathway AI. It is trying to function very similar to human brain and can learn better than the existing model. The current state of AI is to do one thing very well at a time. And what Google is introducing is to use one model to be able to do multiple things at a time. So that gives us a more accurate result in a faster way. So they're trying to simulate the human brain function. And that's what they are aiming. So these new framework that they're working on, they're going to introduce one model that can do multiple things at a time. The human brain only uses a small amount of processing power to complete a task, and not the whole brain. So these new AI pathway, they're trying to accomplish or simulate the same way that it does. There is a way, I don't know why my slide is playing up. Let me just go back. Sorry, technical difficulty. So I can explain better when it goes in. So as I said, they want to create one model that can do multiple tasks at a time. I don't know why it's moving for me. I'm not doing anything. Sorry, technical difficulty. So there is a huge article regarding this new architecture, and it is the very basic thing that they're trying to do. They're trying to simulate or replicate multiple sense within the single model. So rather than training different model at different point in time, they're trying to have one model to be able to introduce and have an outcome of different sense. For example, if it's describing an image or reading a text, those two tasks can be done within one model rather than two different models, and then combine those results to single outcome. So they're trying to have a parallel way of training from different senses, and they want to combine those functionality within one single model rather than different type of model. For some reason, my video is not working, but I will share that later on in the chat as well. I will share this link as well, so you guys can go and read around it. They haven't, Google hasn't mentioned that which platform product it has used these new technologies, but they are kind of evolving this framework further as well. I guess they will hear more about it, and they're going to use it in one of their products later on as well. So we'll hear and see more about this new Pathway AI later on as well. For some reason, it goes back to the new, and I don't know why. All right, let's go back to the next All right. Going back to the new way of AI and ML world, there is a new research that MIT has started doing, which is kind of to understand the relation between different objects. But so going back to how Google is trying to improve or evolve the new framework or the new architecture that they have, this is kind of a similar kind of research that has been done. So what it does is, as I said before, each model does one thing at a time. So what they're trying to do is try to understand if it's like two different objects, they're trying to understand the surrounding around those objects, or they try to understand the different a relationship between different objects. So it can describe, for example, an image in better sense, and also it can be used reverse as well. So it can get text. It's not only an image or visual training or visual model that it can use. It can be a reverse kind of. It can be used in a reverse kind of fashion as well. They call a new technique called energy-based model to represent each individual object at a time, and then combine the results. So I believe Google AI, Pathway AI, is using similar kind of framework underneath, but they kind of empower that framework or elaborate on that framework a little bit more to make it more powerful. I'm going to share that link as well with you guys that you can use. It is a search that has been it has been done, but they are still working on it. So I guess there will be more outcome or more result will be shared later on as well regarding to that one. The very last news that I want to share, I hope I still have time. Yes, I do have time. Is it didn't go back to that slide, but it's going super fast. I don't know why. I have to change my lap though, I believe. All right, I'm sorry. The very last news that I want to share is a new canvas that AWS has introduced for their ML Studio. So it's actually based on a SageMaker, but it's a no-code, which I'm all for it, no-code visual no-code framework that especially business analysts can use to be able to create their model. They can they can train their model, and they can get the outcome quite quickly. It supports different languages and different classifications, and it's a kind of very neat way of training your model without needing to know a lot of technical knowledge behind the scene. So it gives you a canvas. So you just need to drag and drop your model and your component, and you can create and train that model and get the result pretty quickly. It was there in preview, but it has gone GA recently, so it's available to be used as well. And as I mentioned, it uses the existing ML capability that it has, which is the SageMaker. So they create a new canvas, so other users or non-technical users as well can use and start building their models and train their models in a more easier fashion. And that was the last news that I wanted to share. And with that, I can pass it on to Sarah. I'm sorry about the technical difficulty that I had. I guess I have to change my laptop. Back to you, Sarah. Can you hear me? Let me bring him up. Oh.
It helps being on stream, not being on mute at the same time. Look, that's some good news coming through in the world of AI. I especially like the one about Samsung Neon. I just wanted to know, that information is not readily available, but I just want to know how far along are they with that natural AI chatbot system that they're building, because it looks very, very interesting, and I can see a number of use cases.
The second video that I will share shortly is actually the guy who's like trying to experience it and explaining it. It goes from the different board and see how accurate each sense of that humanized version of AI looks like and which technology that they use. And he kind of explained how far, how off track it is. But I guess there is a lot coming on that one. And I guess similar to any other AI or ML, the model that we have, it can fine-tune itself, so it will get more smarter as it's going to be used. So it's going to be very interesting. I try to find lots of few more recent articles. One thing that I noticed that they have that in their phones as well. So they actually uses Neon in their phone as well. So it will be interesting. I don't have a Samsung, but I guess it will be interesting to see how it works in their phone as well.
Yeah, it'll be very interesting once they start baking it into their products.
Yeah.
Okay, so what we might do next is I'll introduce our speaker to you. Our speaker's name is, as you can see, Michael John Peña. He's a MVP. He's been an MVP since 2015. He's a CTO for a company called MetaDhana, and I hope I spelled that properly, or pronounced that properly. He deals with blockchain, AI, cloud, and other technologies as well. From what I understand, he's currently in the middle of a major incident that he's trying to resolve. So I would like to wish him the best of luck. And I want to thank him for actually taking the time during this to come and actually present at this user group. So welcome,
I'll be
Michael.
off.
Hi,
Please.
hi everyone. Thanks for that, Sarat. Yes. Yeah, you're right. I'm in the middle of incident, just for everyone watching. Yeah, so in particular related to the topic as well about HCI. Yeah, so we have a major incident happening in the US right now. Yeah, so we're trying to resolve it. I'm literally waiting for it to be 10 p.m. here in Sydney so that the folks on the counterpart will be awake and we'll troubleshoot it.
Perfect. Michael, just before we get started then, a couple of quick questions for you, just so that our audience can get to know you a little bit better. So how long have you been with MetaDhana?
Right. Okay. So probably, like MetaDhana is a new venture that I started with a couple of my folks. Just literally, the idea, we started it around 6 months ago, but we formally incorporated around 3 months ago. But while doing that, I'm still actively involved with my company Datachain, which is um my entity to kind of like do all this Azure ML stuff all over the world. So that's kind of like my entity. So this MetaDhana is more of a new venture that I did to kind of like focus more on the metaverse side of things, but still with the AI as well and Azure obviously as part of it. So yeah, then prior as well as with all of those things happening, I'm also advising to a couple of startups. One in particular right now is Lumachain here in Australia. So they're doing a lot of this edge stuff, on Azure on edge, ML on edge stuff. So I do have a lot of nitty gritty experience with this kind of stuff.
That's very good to hear. Especially on some of the edge technologies as well, because we are looking to actually get into that at some point. So it's good to have your knowledge into what to do basically, and people can reach out if they have any questions. I guess the other question I had quickly is, where are you based?
All right, so I'm based here in Sydney right now. In a suburb called Ingleburn, like near Canberra. It's literally between Canberra and Sydney. So yeah, that's where I'm based right now.
I'm just checking quickly. I'm getting some sort of feedback somewhere. Might be from your speakers, Michael?
Probably from my speaker, right? Let me just turn up my speaker real quick. All right. How about now?
No, I'm still getting some feedback. Not so much I can hear echo, basically. Anyway, what we'll do is we'll get started with your presentation. I'll put myself back on mute. And yeah, take it away. It's all yours, Michael.
All right. Okay. Cool. Thanks. All right. Let me just turn up my speaker here. I think that's what's causing the echo. Give me a second. All right. Okay. I think that's much better. Cool. Can you message me, Sami or whoever on the chat if my audio is okay?
Hi, Michael. Is it possible that you have a YouTube live stream behind you?
Yep. Hello?
Okay, I don't think there's any echo anymore. I think you're good.
All good. Cool. All right. Yes, I'll be sharing my screen. Can anyone put my screen on it? All right, cool. Yeah, so as Sami was mentioning news earlier as well, I don't know if it's has already been announced, but Microsoft also recently opened the OpenAI service on preview. Basically, if you're familiar with OpenAI and GPT-3, now this is an opportunity to kind of like because of their partnership, it's an opportunity as well to kind of like use the Azure infrastructure to kind of like host your consumption model of the GPT-3 models. So yeah, that's just one kind of like AI related news announced recently during Ignite. Okay, cool. So over my presentation, now I'll be talking about ML on Edge with Azure. I think like I'll be covering like the whole Azure ecosystem here, in particular around the ML aspect of it on Edge. And as part of that, I'll be also sharing a lot of journey and like really it's more around a personal flavor of the journey of having a kind of like real world experience and like real world troubleshooting experience with the product rather than just really showing you the what's and nuts. All right. So in terms of where I am right now, so yeah, I mentioned there's MetaDhana that's really focused right now on my venture around metaverse. Still involved with Lumachain. We're doing a lot of those ML on Edge. And Datachain is kind of like my entity to kind of like advise and assist customers all over the world with their Azure ML on Edge journey as well. And yes, I'm a Microsoft MVP. And I think as part of it is that I'm a lifelong learner and community contributor whenever I can. I'm really passionate about this stuff, so that I get to kind of like share my stories and experiences as well, and at the same time, hopefully inspire others to kind of like understand if like for example ML on Edge is on Azure is a fit for their current scenarios or current use cases. All right, so to begin with, I'll kind of like go back, like it's gonna be a story, right, that about the hybrid cloud ML journey, if I might say, right? Like it's not just about ML, it's not just about cloud, it's also about the hybrid aspect of it, right? And how come how did we come up to where we are right now? We're in there are ML everywhere pretty much, right? Whether that's on Azure, AWS, Google, or Edge, or legacy servers, or even just your PC, your mobile phones, or anywhere, right? So I'll just be kind of like sharing a little bit of like history around it and how it kind of like unfolds into where we are right now. So back in the days, if anyone remembers, there's a concept of an on-prem infrastructure wherein companies to host their applications and databases, that they have to kind of like really own the hardware clusters. They have to set up their own IT data centers and stuff. Very expensive, very high capital requirements. But like even back then, the concept of ML and AI obviously has been in existence. It's just that the turnaround time for data access, especially back then, is kind of like long, right? So for someone, and the model back then is very similar to like application putting in some data on a database like SQL Server, and then you come up with like data warehousing, and from that data warehousing solution, that's where someone like a data engineer or a data scientist can experiment on. And that whole ML ops or AI ops thing doesn't exist yet during this time, or probably it's not as seamless as it is right now. But yeah, I mean the whole point there is that running ML models back then means that it's already in an isolated environment on a physical data center, right? Like you're gonna host it on a Linux server in a data center, and if you come to think about it, that on its own is arguably probably can be called now an edge infrastructure, right? Like because like we're coming to a full circle now about that same topology 15, 20 years ago is coming back, but on a smaller scale. Instead of like, a very wide range set of hardware, it's now becoming, a very commoditized, cheaper, and very portable set of devices. So that's just my personal observation, that we're actually going, like full circle of where we've been 15 years ago in terms of, the topology and the network design of things. Then af- like obviously during probably 2010-ish onwards to 2013 especially, the race for cloud happened. And AWS, Google, Azure are all in that same space, trying to do a lot of those lift and shift migrations of applications and databases, and that results into for data scientists and ML engineers. That means a very easier access to data, right? Like and at the same time easier access for virtual machines on demand, right? Like instead of having a procurement process back then of, hey, we have to buy six racks of servers to host Linux and install everything in there for our training. Now this activity is very much commoditized these days because of this whole multi-cloud happenings, right? And the thing is, now we're more than just the ISO cloud, as we call it, like like a company invested into just one cloud provider like Azure, AWS, or Google. A lot of the trend that happened, especially probably 3 years ago, even up until now, is having a multi-cloud strategy. We're in some cases, like companies use bits and pieces of whatever services that these cloud providers give. Like a common pattern that I've seen is that companies uses Azure for the Windows servers, SQL servers, and database and apps. Then the AWS is more on the public facing ones and like high compute stuff with Kubernetes. And then with Google, that's most of what my observation as well in the field is, that they're more focused on the ML AI operations. But yeah, I think what's happening now is that we're now seeing a lot of this mix and match instead of just a single kind of like provider for everything. Yeah, and that kind of like avoids the cloud gravity, as we call it. Like if you build on one cloud provider, you have to learn that cloud provider, and you just have to build specifically on that cloud. So less and less of that is happening. Yeah, mainly driven by containers and all those more commoditized set of technologies, like infrastructure as code for one. Okay, so now edge infrastructure. So now just like I mentioned earlier, right? To put it simply, an edge infrastructure, little bit typo there, sorry. An edge infrastructure is like, think of it like, instead of having a big data center, right, or mostly hosted on a city or in a metro area, this time around, we're now looking at harvesting data on a site that is probably remote and probably doesn't have a lot of access to internet connection. So yeah, so that's probably the most like good use case of an edge infrastructure, whether that's in transit, like let's say shipping vessels, planes, like mining companies on their trucks, and all those IoT stuff. But at the same time, it doesn't have to be just those things. We can also look at, let's say factories, processing plants and stuff. that's not really into in a metro area, but they do have a infrastructure in place that has capability of of compute and networking. And now you just want to kind of like onboard a general purpose or sorry a per, a specific purpose set of devices that will do the AI or ML operations. So most of the time, the pattern that I've seen or what I've experienced firsthand is that like number one use case of edge infrastructure, in my opinion, is vision, right? So a lot of companies right now, or a lot of factories and processing plants and remote facilities, most of them already have some sort of like a CCTV system, like cameras installed with IP. Most of them are IP enabled cameras that stores streaming data on a NVR or or a storage of some sort with still within that facility. And most of the time, um, the initial challenge back then was that if I want to apply some AI or ML, inferencing on this set of footage, well, how will I bring all of those video data onto the cloud, right? Onto the public cloud. Um, yeah, so if you do that, well, one, that's possible, but two, it's expensive, especially, if you're actually comparing about, if you've done your analysis and computation about the network throughput that you have to consider of, if we're talking about terabytes of data every day, being sent over the cloud, regardless how cheap the storage is, right? Like if maybe an S3 bucket or an Azure storage is cheap, but the network throughput is actually something that kind of like really hurts the budget, right? That's really what kind of like hurts the budget in terms of implementing the video footage streaming on cloud real time and doing the inferencing in there. So that's why an edge infrastructure would be much more appropriate on those scenarios, because like put on your ML model instead of on the cloud, put it on edge, right? Do your inferencing on edge, right? So that means one, the data, the video footage doesn't leave the site, right? So it's still stored on that NVR or on that storage of the site. And two, you save a lot of costs with the network throughput, IO, going up and down from the cloud. And third is you are actually going to um, like the 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 um the the way you will design your application is actually gonna be more catered towards a specific site, which is kind of like one of the key learnings that we had later on, right? Especially when working with ML on edge, something that we kind of like learned early on is that it's hard to come up with a general purpose model that will really work on all facilities all over those different sites that you own or sites that you manage, right? Most of the time, based from what we've learned, is that all of them are different, right? Like, and a lot of them are not very reusable. So like key factors in place is one, camera position, they're all different. Two, um, lighting, like at the same time, some of them have different camera models as well, different networking infrastructure, different networking kind of like topologies. Some of them have supports 5G, some of them they prefer to be part of an internal network of that specific site. So yeah, so kind of like key learnings that we had there is that if you're designing an ML on edge, make that specific model designed on that specific site. But that doesn't mean obviously that whatever you learned there, you can kind of like apply some of those techniques as well on other sites, right? But what I'm saying is that it's hard to come up with a general purpose model that will work across all those sites, across all of those edge infrastructure. So then as part of that one, most of the time, what you're just sending towards the cloud are the telemetries. So like, for example, if you're doing some detection or alerts or some sort of, like whatever inferencing results that you want, that's probably the only thing you want to send over to the cloud. And that would cost very cheap because those are literally just kilobytes of data or even megabytes of data every minute or so, compared to streaming the whole video up there and doing the inferencing up there. So yeah, that's really one of the key reasons why it's probably best to apply ML on edge. So, but now, what's happening now is that we're now seeing a much more unified hybrid cloud, wherein just like I mentioned earlier, data centers in metro cities are still there, multi-cloud happening all over different cloud providers, and your edge infrastructure happening in there. However, the pattern that's emerging is this concept of like a unified hybrid cloud. Wherein, for example, in Azure we have a service called Azure Arc that kind of like allows you to install an agent across different, whether it's a server or Kubernetes cluster or even just a VM, right? Um, yeah, so it kind of like allows you to capture telemetries across those different providers or different infrastructure, and it's a unified experience that allows you to kind of like react properly and allows you to kind of like like maintain stuff, right? Most of the time what happens here is that like, for example, one of the ML models are not working properly in one of the sites. What's going to happen is that the the inferencing model will send an alert saying that no data or no data being captured or stuff like that. Then that in itself is already a good kind of like proactive safe, not safety, but proactive tool for you to use so that you can react appropriately. Then once you've received those set of alerts, now you can kind of like investigate further. It turns out that those cameras are foggy, right? Because let's say someone did a general cleaning on that day, and like someone actually, threw in some water on those cameras. Hence, the vision is also blocked. So yeah, so having this unified kind of like unified monitoring or unified hybrid cloud experience is really key in order, like for that edge infrastructure to be like scalably feasible, right? And economically viable, right? Because the worst thing that could happen is that you set up 10 different, you know, um, networking sites, like networking topology across 10 different sites. You set up, 10 different hardware infrastructure on 10 different sites, and you created 10 different ML models across those 10 different sites. Now you have to maintain 10 applications. So that's kind of like just a big overhead in terms of this whole maintenance of things. Yes, containers. So uh, I think the key as well is that what makes this whole thing really kind of like more, I would say, more seamless or less frictionless. It's probably frictionless in terms of like being more agile or being more iterative with your deployment is the having containers in place. Okay, all right. Just give me a sec. Something just happened on my back. All right. Sorry about that. So yeah, so for example, having the concept of AKS or Kubernetes is really good, so that whenever you push in a version upgrade of your model, or whenever you have to deploy a new runtime environment and stuff like that, having that in place is already a good thing, so that you don't have to kind of like maintain each and every server separately, right? So having that concept of a more desired state configuration is already really good. But on edge, ACI, probably not so much. Registries, obviously, you have an option to use registries either on edge or use a registry on cloud, and you just push those images on edge. So most of the time, what we do is that we have a master copy of a container image on site, right, through that edge registry. But then all the iteration, or the minor version, are happening on cloud. Yeah, but the major version, we kind of like have a like stored per each site, so that we kind of like have so that the time comes when we have to kind of like roll back or roll forward, we kind of like easily maintain that, hey, for this site, these are the versions that we want, and for that site, yeah, those are the things that we want. Yes, so app services for containers and Azure Container Apps are the new things. But yeah, they are not yet supported on an edge environment or in a like HCI or stack edge environment yet. So the typical team topology that happens, or the way we usually split this, right? Like, for example, if there's a customer that wants, ML or vision on edge and stuff, so we kind of like split this into kind of like three teams, or at least three representatives for each team, and then three different kind of like workspace, if I might say, right? So the first workspace that's very important is obviously what's happening on the customer's edge infrastructure. So for example, something like an Azure Stack Edge or HCI is something that we have to deploy physically onto that site, and we have to set up the networking of it to that to make sure that it's part of the internal network, that it can consume all those IP cameras, all those NVRs and streaming footages. Second is that on cases we're in, we have to integrate with custom scanners, IoT devices like QR code readers, most commonly. So they kind of like have a local database of some sort that we kind of like have to shallow copy and like capture that as well going to the edge. Yeah, and the key here is that this, for example, something like HCI or Stack Edge, it has Kubernetes on it. So that Kubernetes already kind of like allows you to deploy any sort of like application and runtime that will enable you to host your model, host your your modules, like a simple health check module, or your custom modules, or something like customer business specific modules. Yeah, you can all package that as a single either Docker file or container image that you can push on edge. Then the way telemetry works here is that the way telemetry works here is that as part of Kubernetes on Edge, you can install an IoT Edge runtime, right? That IoT Edge runtimes allows you to communicate through an IoT hub, right? So, but at that point forward, once you push those messages to an IoT hub, that's already on cloud, right? Like you can do whatever you want on that data moving forward, like whether that's you want to put that on a database or put that on a storage or anywhere else. Yeah, you have all the options in there. Or usually the common thing is that we kind of like have a function that kind of like captures those telemetries and pushes that to a database or Cosmos or anywhere else, or even all the way to a data warehousing. Then the other part of the logging is Azure Arc with Monitor. So as part of this as well, with Kubernetes on Edge, you can enable the Azure Arc monitoring of it, so that you'll know if which modules are working, which are not working, and you'll have some logs straight from Azure without having to remote access this Edge or HCI environment. So yeah, again, very, very useful. Then from that, yeah, we have the dev team usually doing apps, kind of like creating those real-time applications that's dependent on those telemetries. That's kind of like what they do. They work on either web apps, mobile apps, or any sort of stuff. Then, sorry. Then the AI team, in this particular one, we're using something like AWS, wherein the AI team uses SageMaker, S3 bucket, and stuff. So the end goal is having an Onyx model. That Onyx model is part of that set of modules in there that you kind of like package as a container. And that container, again, right, like that's something you push over to the edge. Question here most of the time is, what data set are the AI team going to play around? Or what are they really kind of like create a model for, right? Or how are they gonna get the camera footage to play around? So the common pattern that happens there is you have 2 to 3 options there. So depending on the agreement with the customer, obviously, because that's really the most important one. That most of the time, this live video feeds are very sensitive data that we have to really take a good consideration of, that we can't just like play around with them and just publish on YouTube or anything like that, or even on talks like this. You can't just do that. So option number 1 is we like when we began this journey, what we did was kind of like created a secure drive that we can physically sorry, even before that, we came up with a solution that from an NVR on that side, someone from that IT team have to copy that through a hard drive, an encrypted hard drive, and ship that to us. And yeah, we have to it's encrypted, so we have to unlock it properly and stuff. And that's kind of like how we play around with the videos of that customer. The other option that we also came up with is a secure FTP, or a more token-based access to their secure drive. Then the third one is something we just kind of like adapted recently, is that we used a storage, but using more of the SaaS-based access of it. We're in like them pushing the data over to the cloud using SaaS, like secure token, and at the same time, that kind of like like we create a proper life cycle management when it's already on that storage, right? We kind of like create a proper life cycle management of when to delete this, when to treat this as an archive, or when is this something you would call still relevant for future training and stuff. So yeah, those are kind of like the three major options that we kind of like explored with. Obviously, the option of having that live stream, or like, someone can just kind of like, like have access to the NVR and capture any video anywhere, that's out of the picture, at least most of the use cases that we explored into. We totally ditched that. We totally don't support that model. Like making your IP cameras, your CCTV feeds fully available on the internet, regardless if there's encryption in transit or at rest. We never supported that at all. All right, yeah, so the ops team, pretty much covering all this blue box. They're the ones kind of like maintaining all of this through monitor, maintaining, setting up ARM templates so that dev people can use, as well as at the same time spinning up VMs, spinning up VMs and spinning up workspaces for the AI team. So that's all there. Most of the time, the ops team are the ones handling that. And in this case, the ops team are also very much involved with the customer team, because they need to make sure that this connection works and this connection works. Yeah, and it's one of those things that's it's really easy to say that it works, or it's very easy to just follow a set of instruction, but there are a lot of complexities in place, especially in the networking aspect of it. At times it's very easy to really be there, at least on kickoff of the project, to kind of like set it up properly, rather than spending a couple of hours every day rebooting the server, setting up DHCP, static IPs and stuff. Yeah, so that's kind of really one of the key learnings that we had as well as part of that. So this is kind of like a more modern, or a more Microsoft-y architecture that we're adapting recently, in terms of how do we actually package everything, or as we grew from like starting with hard drives and starting with just using my laptop to begin with, like 3 or 4 years ago, to train the model, like those HD5 models and stuff. Yeah, so now we're more evolving into a more end-to-end offering, or like an end-to-end pipeline, if I might say. Yeah, that's really kind of like captures the whole essence of an end-to-end ML journey, and end-to-end ML lifecycle and data lifecycle journey as well. So same thing as the one in the previous diagram. You have your edge infrastructure, IoT devices, CCTV system, stack edge or HCI, Kubernetes on edge, reporting to Arc, then yeah, registries. Then what we've learned as well is that like we are now adapting with AKS for the web applications as well, web backend applications and stuff. Mainly because of the messaging aspect of our applications. We kind of like have to make sure that they are properly routed, they're properly can communicate to each other and stuff more seamlessly and more maintainably. There's a word for it. Yes, and what has changed as well is that from IoT Hub pushing straight to functions or stuff like that, what we've learned to adapt recently is we've identified to use stream analytics much more. We've found the value of having this, especially when we have a high, high concurrent number of messages coming through from those ML on edge. Like, for example, if we're working with 10 or 20 cameras, we really that means we have at least 10 data source, and per camera we kind of like captures probably 5-10 messages per second, as part of, like, let's say a conveyor belt of corn, or a or any sort of like product. Yeah, like there's a bunch of stuff happening in there, and you kind of like have to capture that on scale. And yeah, so something like stream analytics would really be handy to kind of like just capture all those messages. Some of them won't make it, but at least as an aggregate, we kind of like support, at least probably 99% of data being sent. Yes, so the other thing is that we are investing a lot with Synapse as a kind of like end-to-end data warehousing ML workspace as well. In conjunction with Azure ML, to kind of like have that, pairing of Azure ML is everything ML stuff. Azure Synapse is all thing data warehousing and like data stuff, data engineering stuff. Yeah, and at the same time, we've also come to consume a lot of external data warehouse, data warehouse databases as well, and databases. And at the same time, we've also captured a lot of semi-structured and unstructured data from various sensors that we may or may not be owning, or maybe the customer is the one who kind of like owns it. So yeah, so having this Synapse as a unified kind of like data aggregator really helped us kind of like, as well as assist the AI team to kind of like have a much easy access to data. Like instead of, again, the story of 15 years ago, like they have to wait days or even probably 14 days, like 2 weeks, just to have a snapshot of a report from a database. So now we're talking about like almost real time. I'm not saying real time, like almost real time, probably around 2 to 3 hours real time, at least where we are right now. Yes, then we kind of like evolve as well into using something like Power BI for internal reporting and something like Grafana for external reporting of those, either devices or telemetries or whatever graph that we really want to support. Yeah, and Cosmos is just our way to go right now in terms of any application related data that needs to be served. Okay. Then the other bit as well is that we've extended, using something like from AKS API management, we also extend it to like HoloLens, yeah, like and other application as we evolve, like for example in a processing plant, those telemetries that the cameras were capturing, sometimes it kind of like good to visualize them on HoloLens or any kind of like a more immersive experience. So we get that through the API management as well. Like for example, if you want to visualize the yield of let's say a specific set of product line, yeah, so having an immersive experience of seeing percentage or charts or reports at the same time, like probably an access of an incident, like someone's not using gloves and stuff. So yeah, that's kind of like the evolution of the application beyond once you've set up those ML or infrastructure on edge, right? So there's so much stuff you can do once you already have the data and the ML running on it. So all those smartness and all those capabilities, you can just kind of like really innovate on it. Just spend a lot of time tinkering. What can you do with this data? So yeah, so probably like it's kind of strange for like, especially for people, for other people who are actually especially if you're in a data science background rather than an engineering or infrastructure background like me. So for them, they're more geared towards the GPU offerings, like let's say NVIDIA or those stuff. Like the question that always comes into place is, why Azure, right? Like, why would you use Azure, or why would you use Azure Stack for this? For this scenario, like, well, number one is that as much as we've by the way, we've also tested a lot of those NVIDIA stuff and other general specific purpose GPU accelerated, FPGA accelerated hardware to kind of like work with. But the key aspects of it boils down into one, the what we're doing most of the time is that beyond the ML and the beyond the ML and the inferencing side of things, right? Most of the time you would also need some sort of like application that kind of like general purpose, right? Like that runs on a container and stuff like that. And we found out that it's not very economically viable to kind of like say you have a specific hardware just for the ML, and you come up with a general purpose server for the compute and storage part, right? So we tested that. However, one key finding is that the cost aspect of it is kind of like it's two cost thing you have to consider at the same time, right? Then the other aspect of it is that you also have to kind of like hardware to maintain, right? And once we talk about scale from day one, right, we envision that we want to have less hardware really, or we want to have less kind of like like micro bits and pieces that we have to kind of like massage and maintain all the time. Like, we don't want to end up having 10 different hardware offerings across 20 or 30 different kind of like sites. So what we want is that kind of like a more of a tier-based approach, right? Like, for example, do you want to just start with 5, 10 cameras, or probably 3 cameras? Then we use Azure Stack Edge. Easy. One GPU, 2 GPU, or FPGA, whatnot, right? That's easy. Are we talking about 20 cameras? How many lines? How many stations? Okay. Then if that's the case, then let's consider HCI, right? Like, we buy a hardware from Dell or HP or whoever. Then we set up a software that's kind of like familiar for us. Then the third part is it's probably more than just the edge stuff. We might actually use this infrastructure to host applications, real-time applications. Like, people within that area will also consume it real time. So that's where something like a hub, a set of a bunch of racks of HCI on a hub would make more sense, right? Costing wise, later on, we've computed that the managed service aspect of it, like, let someone flying over there back and forth, setting up things, enabling VPN, enabling RTPs and stuff. We've factored that already. So that's why we really like Azure Stack in this regards, because it's a very tiered approach of like which one to use. And not to mention, the software patch is very it's very user friendly, if I might say, right? Then someone might argue, well, that's why you use Kubernetes, right? Well, that's why you use Kubernetes. But then at the same time, you have to maintain Kubernetes on edge as well. That also needs to be upgraded. So so something like HCI and Stack Edge have that capability to upgrade Kubernetes, the managed Kubernetes aspect of it, so that you don't have to. And lastly, familiar Windows sysad experience is very similar to Windows Server management, if you're in that space. And a managed service offering a lot of partners all over the world to partner with, a wider ecosystem of, again, coming from that traditional Windows Server partner ecosystem. This is an emerging market for them that they're supporting, right? Compared to the new ones the new ones that are just starting with their service offering, they don't have that much partner ecosystem yet. So like right now, like if I wanna, work with someone from Latin America or in Northern Europe, there are already like partner channels in place that kind of like say, all right, they'll be the ones setting up, the CCTVs, buying the hardware, blah blah blah. They'll also be the ones setting up this, and that, and the also a discussion around who maintains on which Azure tenant, things like that. It's just a much more formal, a much more enterprise grade discussion rather than, hey, these are the hardwares that we want. Like, let's hire someone to literally go there and set these things up with the customer. So, yeah. So the experience is really good with terms of that, service offering, partner services. So I'll just quickly show the HCI dashboard because this is probably something that's not very easy to do. For one, because that means you have to have an actual HCI to see it. But yeah, so like to kind of like paint a picture of what an HCI cluster would look like, it's basically like this, right? So if you're again familiar with the Windows admin side of server things, it's a very similar experience. It's all GUI, graphical user interface. You manage a bunch of clusters in there, a bunch of servers within a cluster. So they're all in there. You create your gateway and stuff. Then, like for example, if we go to something like the the SU2 cluster, you have capabilities to create VMs, right? So that means that for some reason, like let's say specifically for ML, if you want to create an ML workspace on that edge environment for some reasons, right? This could be an option in there. You can add a new VM, set up Ubuntu or any other OS of your choice and use that. Servers is basically if you didn't set it up as a cluster, you have the capability to maintain VMs as a server, or you can like maintain them as a server. Then the other bit is AKS. So this is new and really kind of like again me going back saying that this is a game changer because this means that theoretically your containers on AKS on Azure would work on AKS on Edge. Theoretically, okay. Obviously, you have to factor in a lot of things as well in this regards. So I didn't set this up on this one, but I'm basically saying that hey, AKS is available on HCI. Okay, so and this is becoming the much more popular deployment model for ML on Edge as well, and not just ML on Edge, even something like PostgreSQL or simple Nginx runtime and stuff, reverse proxies. We kind of like default now to AKS in that regards. And storage, just to show you, with like AKS, with HCI, we're talking about we're talking about volumes with terabytes and terabytes of data. Obviously this is not in a running state, this specific cluster, but we're talking about drives with 14 terabytes of reserve, and we use something like 30 terabytes and like 25.8 terabytes of resource to host all of this stuff. So yeah, this is not something that kind of makes sense to those general specific those specific GPU accelerated devices, right? You need a proper cluster to host those applications and host those ML models and stuff. So yeah, that's why having this, something like HCI is really a good kind of like unified, not just unified, but a more maintainable experience to kind of like project, hey, how much memory do we have? How much space do we have? Yeah, you can set up replicas, virtual switches, SDN infrastructure as well. Like for example, you wanna properly network AKS. Like for example, you want to set up a bunch of VMs separate from AKS and stuff like that, or multiple AKS per different customers in a single HCI. So these are all the like networking bits and pieces that you can do. And just like I mentioned earlier, Azure Monitor is really good, so that for some cases that you don't want to go to this, like quite slow experience, because this is literally the actual HCI over in the US right now. You can just push monitoring across, create a log analytics workspace over on the cloud and do that bit. And again, updates, very, very nice. Like you don't have to manually patch it. I mean, you still have to click some buttons to get there, but yeah, the updates experience are really good. Diagnostics, performance, security, it's all in there. Like settings as well. Like, because for example, like if you, like once you're in a specific, let's say server, you have the option to use PowerShell as well to kind of like, hey, I want to deploy, this ML model on this specific server on this cluster. So you have that capability. Yeah, like for example, HC1, SU1. Yeah. So you have the capability to maintain a bunch of servers in there, monitor their performance. Yeah, you see, we got like 24 cores of one processor, but 24 cores. Yeah, so 288 gigabytes of RAM per server. So that kind of like supports a specific set of like environment that probably can support up to 15, 20 cameras or even more, depending on the complexity of the model. Yeah, and this inbound, outbound, right? Like this is kind of like very important, especially when trying to understand the behavior of those those edge cameras and stuff. Yeah. So overall, a very like maintainable experience to as an ops person. Like then that means for later on for the ML person or the data scientist, the infrastructure will kind of like be very not very seamless, but it's easily available for them, right? So yeah, just a bunch of stuff in there. Going back here. Right. Just oops. Okay. So going back here, for example, using PowerShell, you can like use again Kubernetes on PowerShell and like basically using a commandlet like AKS HCI. That's kind of like the commandlet that you use in order to kind of like maintain or deploy or configure your cluster, your AKS cluster inside an HCI cluster, and kind of like see their like configuration settings and stuff. Like for example, you can set up an AKS cluster with a Linux node pool and deploy a bunch of containers in there. And yeah, something like this, you can kind of like tear down the number of nodes up and down. Like for example, if you kind of like want to start with 2 nodes, then you probably want to kind of like decrease the add a Windows node, right? Or decrease the Linux node or create a control node. So all of that is very much configurable in the HCI experience. So lastly, with the, like once you've set up some Kubernetes on HCI, if you're familiar with Azure AKS, this look and feel is very similar to Azure AKS, wherein you have the capability, to kind of like set up GitOps policies, monitorings as well, and stuff like that. So one thing that's also in preview is the AKS to even have a further network security group policies in place, so that it allows you to even have a much more secure enclave of, let's say, all these related containers only. This specific AKS only is part of this specific set of private network, let's say those IP cameras and NVRs, so that they're isolated across the other AKS clusters as well. So lessons learned. One, the big caveat with having ML on edge, in my experience, or at least what I've learned, really very, very big dependency on hardware and network operations. So majority of the work that we intended, the complexity of it is mostly setting up the hardware and networking. So that was really the biggest kind of like lesson learned that we had there. That's why we're still very thankful, when doing prototypes and stuff, obviously cloud first will always be the approach. That's why when we are working with a customer, we want to experiment with creating a model and stuff, we want to do that experimentation on cloud rather than on edge, for obvious reasons. Again, of that means we have to set up hardware and networking first before doing that. So very just factor that in mind, that you have to really properly set up the hardware and networking operations in order for your ML on edge to kind of work properly, or else you might, again, time and time, we kind of learn to be more detailed about stuff around it. And yes, so automation is key. Despite having a bunch of PowerShells, a bunch of ARM templates, a bunch of Docker images and stuff, some things is really something you just really have to work in detail, because again, once you talk about a lot of applications, a lot of modules, and not so much people in the team, then you kind of have to make sure that it's easy to troubleshoot. Monitoring, it's very important. We actually haven't thought about it in the beginning properly, but in the on the latter stage, that's when we kind of really understood the essence, or the importance of monitoring beyond just seeing logs or graphs. That application insights and log analytics, Azure Arc, all of the stuff are very, very really useful, especially once you come up with incidents just like what we're having right now. So there you go. Probably again, as part of that big dependency on hardware and networking operations, unfortunately at this space, for example, physical defects or physical troubleshooting happening on site, needs to be someone in there to still physically do it, or still physically troubleshoot with. So one big lesson learned there. So that's it for my presentation. So kind of contact if you want to experiment onto this one, or if you just really need some guidance around your ML on edge journey. That's my email over there. So we do a lot of that in Lumachain, and my company as well, the Datachain. So that's it. Thanks very much.
Thank you very much, Michael. That was a very, very interesting, presentation on how you do ML on Edge. Like I was saying earlier, we are looking to do something like that in our company as well. So it's a good thing to understand what you've done, how you marketed your solution out across different continents, basically.
Yeah.
So it'll be good to understand from a smart city point of view what can be done in a city. So taking Brisbane as an example, what sort of solutions can be put in place across Brisbane to help people actually get better outcomes out of their city life. Also, with
Yeah.
COVID the way it is, it also would help with things around COVID as well, I'm guessing.
Yeah, exactly. So what in particular with COVID, one of the ML models that we actually came up with is obviously hygiene and social distancing and stuff like those things that some of them might be as simple as just an extension of YOLO or MNIS and stuff like that. But having that starting point deployed on edge, let's say, like on a factory, right, or on a processing plant, that's already a good step forward, right, to play around with, like understand behavior of people, and having that safety net that, hey, this ML is running on edge, we're not uploading this footage over to the cloud, or we're not disclosing who this person is, and
Yeah.
stuff like that. So those are really key whenever we discuss those things.
Yeah, and I'm like, I was just thinking about it a bit more. One of the use cases would be in the healthcare field as well, because obviously with healthcare data, you can't actually publish it online, and they don't want it to leave the premise. So yeah, no, it's a very good thing. It's a good thing to understand. Okay, just quickly looking at the time then. Just want to see if there are any questions coming through from chat. So no. Okay, this looks like there's no questions. What we might do then, we might just move on to closing for now.
All good. Yep.
Okay, cool. Thank you very much. I'm just going to remove your stream from stream for a few seconds, Michael. All right. Thank you guys for attending this event. As you can see, the next event is going to be at the end of December, just before Christmas. We're tentatively planning around the 23rd of December, but we'll let you know more details as we get closer to the date. Just like usual, we'll publish all our event information on Meetup, and we'll let you know on social media as well once it's been created. If you've got any sessions that you would like to present, or you would like to hear about for us to find speakers on, let us know. You can submit your sessions or your ideas on that GitHub site, and we will get that action for you as we can, basically. Okay. We do have a YouTube site as well. We are part of the global AI community, so we do host all our videos, all our sessions on that site as well. Link is given on the presentation, and we'll put that in as part of the separate date. We would like your feedback. Okay, please keep your feedback coming through. It'll help us to understand, what are we doing well, what are we not doing well. Should we keep streaming? Do you like the streaming format, etc. So, any feedback that you provide us is very useful. Okay. And finally, a big thank you to our presenter, Michael, for coming tonight to present on such a busy day and with the problem that he's trying to resolve. And to all our attendees and my fellow organizers for helping to organize and come to this event as well. Okay. I'd like to wish everybody a Merry Christmas if I don't see you at the next presentation. And if I do see you, I'll see you at the end of the month. Stay safe and keep following the COVID guidelines. Thank you very much. Bye.